Welcome back to VTU e-Shikshana program on computer aided engineering drawing. Now let us start topic projection of planes. In projection of planes, we have to know basically what type of planes and what is corner, what is edge or side, etc. Now let us start with a simple model. This is a rectangular lamina. We have square lamina, pentagonal lamina, hexagonal lamina and many more, including circular lamina. So here you have to know what is surface of the lamina. This is the lamina with negligible thickness with particular size and shape. This is rectangular lamina of 100 by 40 or 100 by 60 or 60 by 100, whatever. And corner or 4 corners are there, 3 in triangle, 6 in hexagon, etc. But it's very clear for you. And here there is confusion between edge and side. These are edges. In this particular case, in rectangle, longer edge, smaller edge or shorter edge. In case of regular triangles, polygons, we have in triangle equal sides. Whenever I say triangle, in all these problems we solve or discuss, that is equilateral triangle only, unless it is mentioned. Okay, there may be scalar and other equilateral, etc. Now, whenever we say triangle, it is equilateral triangle. All sides are equal, included angle are 60. Okay, now these are corners. ABC are corners. AB, BC, AC are edges or sides. Okay, so this is about the surface of the lamina or corner or side. Now, as I told you earlier, we are going to deal with rectangular lamina, square lamina, triangle, pentagon and hexagon and also circular lamina. Here are different problems you get. Simple problems on planes, planes inclined only to HP, planes inclined to only VP, planes inclined to both HP and VP. Normally you get this last type of problems for your discussions. Now, let me take a simple model and discuss various aspects of projection of planes. Now, I will place this rectangular lamina in this way. Assume that there is VP, this is horizontal plane. You can imagine the blackboard is VP and this is HP. What is the position of rectangular lamina? It's very interesting to take rectangular lamina because it has got two sides and we can vary the criteria unlike any other planes. Here I have the lamina on HP. The longer sides are parallel to VP. Our shorter sides or smaller sides are perpendicular to VP. So this is how we can define the status of the lamina. Suppose if I change the orientation like this, the lamina is on HP and longer sides are perpendicular to VP and smaller sides are parallel to VP. Okay, this is how we can say the position of planes. And also I can change the lamina and say a triangular lamina has a side parallel to VP and away from it. Parallel to VP and away from it. Now, if I make this type, the lamina has a side which is parallel to it and nearer to it. Parallel to and nearer to it. Even I can define 10 mm in front of VP or 20 mm in front of VP. Okay, possibility is only having one side 20 mm from VP or XY line on projection. And you can say the one of the corner is away from VP. There are many other orientations. Say one of the side is inclined at 30 degree to VP. So this way we can define the position of planes or status of planes. So again I repeat, A, B, C are corners, AB, BC and AC are sides of the planes. Now let me take a simple discussion on first type of planes inclined to HP. See, this is the plane. I have horizontal plane. I can give this position. The lamina is inclined to HP only. Inclined to HP only. So now in this position, the lamina, surface of the lamina is perpendicular to VP. If you project this, you will get always line as the front view. And what is top view? Top view is apparent shape. Okay. If you keep it on HP or parallel to HP, always you get true shape of the lamina. So if I keep it like that, this, and then what is the projection? Projection is this itself. Then you will get a rectangle 100 by 60 say, or 100 by 50. 100 by 50 is the top view. What is front view? Front view is a line that is on XY line, coinciding with XY line. And in this case, if I take this way, the lamina is inclined only to HP, and the side, one of the side which is on HP is perpendicular to VP. Now I am very particular, shatter edge on HP, lamina inclined to HP. Okay, lamina inclined to HP, shatter edge on HP or edge on HP. In this case, the lamina is inclined to HP, longer edge on HP. In case of polygons and also simple triangle, all sides are equal, so no longer edge, no smaller edge. Simply you can say one of the side is on HP or one of the edge is on HP. Lamina inclined to HP. Okay, so you can conclude that whenever lamina is on HP or parallel to HP, on that plane on HP you get true shape. If it is inclined, then you get apparent shape. So apparent shape, that depends on the angle of inclination. If it is 90 degree, you will get again line. If it is 45 degree, it is moderately, you get the plane apparent shape and you get true shape like this. So this is how you can have the problems on planes. Now let me take same way. This is VP. The lamina is on VP now. The lamina is on VP. One of the edge is on VP. In this particular case, the smaller edge on VP. The lamina inclined at some degree to VP and perpendicular to HP. Now if you look from top, you will get line as the projection. That means the lamina is perpendicular to HP. So in this case, it is on HP, you will get on VP true shape. If you rotate about the edge on which it rests on VP, if you do like this, then this is actually the apparent shape you get in front view. Still, the line is the projection on top view. So this is, I refer this particular position in future for all discussion. If edge on HP, whether it is smaller edge or longer edge in case of rectangle, edge on HP, the lamina inclined to HP, it is a matching problem. The edge condition with respect to HP. All the time you see that whenever you want to rotate this, you see that one of the edge is perpendicular to VP. Then you will get a point, that particular edge is a point. About that point you can rotate in the front view. First position, second position. Same way, in this case, first position, second position. The edge on VP. The lamina is inclined to VP. Again, it is a matching problem. The condition is the edge condition with respect to VP. So it's easily you can understand this. Whenever there is a problem, it's inclined to VP also is there with respect to the edge on HP. Let us not worry about that. Let me normalize the situation for any problem. If this lamina is inclined to HP, edge on HP, then it is referred as edge condition with respect to HP. Same thing, if it is VP, it is on VP, one edge on VP, then this is edge condition with respect to VP. So you can solve problems very easily. Once you go through the problem, you can easily catch and then say this is edge condition with respect to what exactly is the pattern to start, whether you have to start from the top view or front view. Now let me take this way, a simple problem. A rectangular lamina of 60 by 40 has one smaller edge on HP, lamina inclined to HP. Okay. Now we have to draw the projection. What exactly the case? If you look from at this status, if you look from top, you will get apparent shape. You don't know the apparent shape. For that, what you have to do? You have to get it true shape. For that, you have to make it parallel to HP. That means if the lamina is inclined to HP, make it parallel to HP to get the true shape on HP. That is very, very important initial condition. Then this is called surface condition. I always call this a surface condition. Now, what is next? Edge condition or corner condition? Whether corner on ground or edge on. Definitely it is edge on HP. Whether it is smaller edge or longer edge, let's not worry. It is only the edge now. The edge condition with respect to HP. The edge to be placed on HP is always perpendicular to VP, so that we can rotate about that and get the surface inclination only with respect to HP. Suppose that somebody may say, okay, why not you keep it like this at random and rotate. What happens? The lamina inclined to both the planes. We are not interested. We cannot draw the projection. At the same time, I'll keep it like this and rotate. Inclination only to HP you have given, fine. But what is there on HP? Corner on HP. I don't want. So, the edge to be placed on HP is always perpendicular to VP, so that you rotate about that and get the inclination only to HP with the required angle. So, this is about edge condition with respect to HP and edge condition with respect to VP. Now, let us think of the lamina which is having a typical situation. I say the edge to be placed on HP is always perpendicular to VP. In this case, this is a typical problem wherein edge on HP, lamina inclined to VP. See, a rectangular lamina has a sharp edge on HP. The surface of the lamina is inclined to VP. In this case, what to do? You cannot follow that edge condition with respect to HP and edge condition with respect to VP. So, we have to think twice before doing this job. Normally, for all the problems which you get is having one edge on HP, lamina inclined to HP, or some other data will be given. Accordingly, you have to think twice, realize what exactly given, and then start working. Now, let me start working problems on planes. Before that, let me use this model which I have prepared already. See, this particular item referred to as quadrant, particularly first quadrant. You are in this direction, you are looking from this direction, this is front view, and this is a rectangle. Same reference I have taken, rectangle, and this is VP, this is HP. This is A, B, C, D. So, this is I have written A, B, C, D. Now, what is front view? If you project, your visual ray will touch these corners and hit again. It will continue up to the plane, principal plane, VP, and gets you A dash, B dash, C dash, D dash. This is called front view. And if you look from top, you will get a line reference. Because it is perpendicular to HP, you will get a line reference. You will get A, B as visible corners, and invisible corners are C and D. Normally, we assume that I am here. You should start from this A, B, C, D. Assume that you are looking from top. Visible corners first, then invisible corners. You should follow this pattern, always clockwise. Okay, so that you can easily denote. For example, here I am looking from this direction to complete the top view. This is the first left corner, A dash, then visible, next visible corner is B dash. This is C dash, this is C, D dash. This is AB visible, CD are not visible. Here I can even define this particular position of the lamina like this. See, here I can say the lamina has a short edge 20 mm above HP, and the surface of the lamina itself is 35 mm in front of VP. It is like this, 35 mm in front of VP. The HP is 15 mm, 20 mm above HP, like this. Like this. The gap is 35, and one smaller, longer edge or smaller edge, smaller edge is 20 mm above edge. This is the situation. Okay. This is the situation. So, how to draw? First, you have to draw true shape. You know, true shape is, say, it is 60, 40. Let us not worry about the dimensioning. We will do it in future. Sorry. This is 60 and this one is 40. Okay. Now, the orientation is this: longer edge perpendicular to HP and smaller edge parallel to VP. So, smaller edge you have to start first. This is 20 mm above HP, and then keep the longer edge 60 mm and then 40 mm. Then project it. You know, for straight lines you have done. Project it. At what distance? Because lamina itself is 35 mm in front of VP, keep it like this. This is how you dimension. Okay. 60, and here you can keep 40. Very rarely you can keep inside, otherwise you can keep outside. So this is how the projection of planes for a simple model. Now let me start a problem. Again rectangle, you will work inclination to HP, inclination to VP, and further you add some criteria with respect to VP also, VP and HP, and complete. Let us work a problem. Rectangle lamina of 60 mm by 40 mm has a smaller side on HP, inclined at 30 degree to VP. Draw the projections when the lamina being inclined at 45 degree to HP. The same problem can be given in different version. Like the lamina has a smaller side on HP. Lamina has a side on HP with its surface inclined at 45 degree to HP. Draw the projections when the side on HP is inclined at 45 degree to VP. Now let us use the model and give information to you. These are longer edges, these are smaller edges. The surface inclination is very important now to start with any problem. Surface inclination, this is, I refer this as surface condition in future. Surface condition. Surface inclined to which plane? Horizontal plane. By both versions you take the HP, the lamina being inclined at 45 degree to HP is there in first version, and second version surface is inclined at 45 degree to HP. Same information. Lamina, this is lamina, this is the surface of the lamina. In second version, surface of the lamina is there, simply surface is inclined at 45 degree. So surface condition means that is inclined at 45 degree to HP. It is very clear now. The lamina is inclined at 45 degree to HP. If you look from top, you get apparent shape. If you look from front, you will get line. But we don't have none of the data. But we can have first data as the longer edge is 60, fine, we can draw 60 mm. Sometimes you get problems of that type also. We will utilize that. Right now, front view is line, top view is apparent shape we don't know. So for that, what you have to do is you have to get the apparent true shape. You have to start from always true shape of the lamina. So when to get the true shape, if it is inclined to HP like this, you will get apparent shape. So this is the normal situation, any problem, inclination only to HP or only to VP. Now let us make it parallel to HP. Okay, so say as the lamina inclined to HP, you will make it parallel on HP or parallel to HP, so that you get the true shape on HP. What is true shape? Rectangle of 60 by 40, no doubt. 60 by 40 is the true shape. That is top view is the true shape. So now I can say top view is true shape in this case. Now you have to start from top view. So whether can we start like this? If you give inclination corner on ground, if I keep it like this and it is again longer edge on HP, but we don't want longer edge or corner on HP, we want shorter edge on HP. So keep this shorter edge perpendicular to VP, then you rotate the lamina about that shorter edge on HP, which is perpendicular to VP, then only you will get inclination only to HP. That means perpendicular to VP and inclined only to HP. So that means you have to start with a corner edge condition. So surface condition is over, you have to start from top view. Then edge condition means the edge to be placed on HP is always perpendicular to VP. So you have to start like this. Draw a line. On this line only you should keep the edge to be placed on HP. So it's like this. This is the top view. So first position, second position. Then we'll think of third position. First position, second position. Now I maintain a gap normally. So if you want to build a house in your area or land, you go for main house, not the outhouse. So don't keep very close to HP. That is for a particular case, you will try to touch it. If situation demands, then only you touch it. Otherwise, you keep it away from it. This is VP, this is HP, then rotate. So maintain some gap. So unless it is given, you maintain some gap. Then let us draw the top view. So this is the top view of the lamina. Dot the figure, it is rectangle. Now naming, once it comes to naming, I have A, B, C, D. I try to incline little bit so that you can understand and see. Assume that this is the direction of vision. A, B are visible, corners A, B are visible, C, D are not visible. First you select left extreme nearest corner, start naming A, this is B, not this one, B, this is B. Next invisible points, clockwise or anti-clockwise. So A, B, C, D. Okay. So keep anti-clockwise. Okay. A, B, C, D. Now this is A. Legibly you write, or in computer you select the particular font. Okay. While working on sheet, you try to do it legibly. So have this projection, and name this point as A dash, B dash, C dash, D dash. Why you are projected on only XY? Because it is on HP, no gap from HP. Suppose that if I have this situation, I would have taken little up. Now it is on HP, so definitely it is on XY line. Just like points and lines, you recall whatever we did. It is on HP means on XY line. Now finally we have the projections of the planes when it is parallel to or on HP. I can dark this 0.5 in the computer, dark this, okay, and also dark this portion with 0.5. That means I can say the lamina is on HP and in front of VP. How much it is in front of, let us not worry. Take something. Longer edge must be parallel, and this one, we are very particular about this. About that we have to rotate. The edge to be placed on HP is AD. Edge is AD, that is perpendicular to VP or XY line. Okay, it's on XY line. Next, we have to rotate the lamina. In this way. First position, second position. So you just observe the front view of the lamina is a line. Front view of the lamina is a line in front view. If you rotate that line, definitely see this is the front view, and then if I keep it like this, this assumes inclination with respect to HP by 45 degree or 30 degree, whatever you give. Okay, but in our case, it is given that take care of this angle. If you do ulta, then you also get marks ulta. If it is 2, 0, then it becomes 0, 2. Definitely understand clearly and do it. Now, the value is given is 45 degree to HP and lamina inclination is 45. Now, what you do is, while working manually, you have to mark the point nearby, leave some sufficient gap, okay, around 1 or 2 centimeters. Then you have to rotate about the edge AD. About this, see, if you look from front, that gives a point reference. This is A dash, D dash. Even you can do this. Instead of AD, you can keep BC. First position, second position, or first position, second position. BC also you can have. But always you try to keep left one in case of laminae. First position, second position, so that you can have judgment, management of space is important. You can manage space very well if you do like this. Suppose that if you keep BC as on HP, it may overlap like this. You have to keep level away from the figure, first figure. So always you keep first one. Next, you have to rotate this by 45 degree. Draw a thin line first in case of manual drawing. Then take this with compass, or you know very well that it is 60 and mark. Okay. This is how you do it. See here, dimensioning for the first figure only, do it neatly. This is 60 and here is 40. Here sufficient gap you have taken, you need not worry about the dimensioning. Now, this is how you create the front view of this type, okay, that is inclination to HP by 45 degree you have given, and then draw dark line for this, for the length of first figure front view. First length of first figure front view, you must keep it here. Take this with compass and draw arc. Okay, now the name of this point end is B dash C dash. C dash. Whatever is available here, you must keep it. Dimension it. Dimension the value. Okay. Okay. 45 degree. Carefully you dimension. Okay. Now I have made inclination to HP by 45 degree. The corresponding top view is apparent shape, not true shape, because it is inclined. If it is inclined 90, you will get again line. If it is 45, moderate value you get. If it is again 0, you will get true shape. Now, as the angle increases, the length, the shape decreases. Draw vertical projector of BC and then draw this. I suggest keep rightmost projection and also bottommost projection so that you need not do extra. So, in the computer, your alignment indicator is there. You come up to this point and touch here and move. Alignment indicator always gives you the signal. This is how to do it. Easy, very easy. Here you have to go for some intersection so that manual working will be easier. Now project this up to here and again project. Stop here. This becomes your corner A, this is B, this one is C, this is D. So the projection of the lamina when it is inclined only to HP is another rectangle, or it may be square for a particular angle. That type of problems also you are going to discuss. Whenever the top view becomes square, what will be the angle you have to find out. That's all. Here angle is given, you are going to get the top view as apparent shape. Now the top view you draw 0.5 you maintain in case of computer drawing. So this is first figure top view, front view. When the lamina is on HP, okay, on HP with a smaller side on to be placed on HP. Now this is the case. You look from top, you will get apparent shape. This is front view. Now first position, second position, first position, second position. Now right now AD which is on HP is perpendicular to VP. I don't want that. I want this to be when the side on HP is inclined at 30 degree to VP. So here the difference between first version and second version, he has started with smaller side on HP. There itself he has given inclination for that. Okay, many people think that it is inclination for the lamina. No, it is again it is mentioned here. Think twice. Completely read the question. First position, second position, then third position or third position. Always you take the lamina away from XY line or VP, because if you do it like this, if you take that line at random, it may cross XY line like this. So always you take like this. AD you keep nearer. So you rotate like this and then place it. So what you have to do is to get third figure top view, keep the lamina, keep the second figure top view. See, I will just say to get third figure top view. How to get it? So this is done by redraw second figure top view by keeping AD on 30 degree line. So redraw second figure top view top view such that AD is on 30-degree line. I have kept gap because what is AD? 40 mm. Here also 40 mm. True length is maintained because it is on HP, no change in length. Okay, so this is true length. Again, this is true inclination. So it is true length on true inclination. Sometimes apparent angle will come, beta angle. So we will discuss that at length in future. Right now, the top view is square, sorry, it's a rectangle, it may be square sometimes, or apparent length, apparent shape actually, it is 45-degree. Now, what you have to do is, as I told you earlier, better draw a line at an angle of 30-degree. So, draw 30-degree line. What for we have drawn this 30-degree line? It is for getting the inclination to the edge on HP. Okay, now it is leaning downward left. Okay, you can also have different version. I will tell you in future. How to redraw it manually? Take this distance. You know this is 40 mm exactly. You can, otherwise you can take, start from D. D you can start from anywhere. If they specify the nearest car is 10 mm or 20 mm, then you can maintain. Otherwise you start from any random point but nearer to XY line. This one. Next, take DC value, that is longer side becomes smaller now, apparent length. Now draw two perpendicular lines, take compass, mark here in case of manual drawing. Take this distance and mark there. Then name it CD, this is A. Join them. See that the second figure top view is drawn. Many times what happens in hurry, people keep first figure top view only here. That means you are not given any inclination to VP. You are kept like this and then drawn. Wrong. So, and also here you are already given, then you project the same thing. You wrong answer. So, always you see that second figure top view is to be redrawn. Okay, accordingly. Now, try to dark this. Okay. Now, this is the final top view. Okay. First figure top view, second figure top view, final top view. How to get it? Redraw this figure such that the edge on HP is on 30-degree line. So, this is true angle, true length. True length is always associated with true inclination. Okay. No beta business here. Now, how to get the final front view? Many times, you know, I have seen people keep long lines up to the beyond the figure. Not necessary. Here we know very well that AD is very much on HP, that is on XY line. This is A dash, this is T dash. Mark only up to XY because it is on XY line. You see the locus. Then project this and get here. This is AB. ABCD. This is B. Stop at this point. Again stop at this point. This is C dash. This one is B dash. Project carefully and join them. Join accordingly A to B, B to C, C to D. This is how you get the final projection. First figure, second figure. This is called change of position method. In your syllabus they have mentioned change of position method. That means first position, second position, third position. I am changing the object. Change of position method. First position, second position, third. So in one more method is the change of ground line method. There what we do is we try to take this. We change the ground itself like this. Instead of giving inclination to the lamina, rotating this, we change the HP itself and call this another ground. Ground 2, ground 1 or like auxiliary plane. So we are not going to deal with that. So don't get confused. Why I have told you, because it is mentioned first change of position method only. This is what change of position method. This is the final solution for the given problem. We will work out the same in software. At the same time, you can also work the problem only with small change. Instead of smaller side, I can say longer side. Here also longer side. Then what will be the first figure? Remaining procedure will be same. What will be the first figure? First figure, let us see. It will be like this. First position. First position is like this. First position, longer side. The item to be placed on HP or edge to be placed on HP is perpendicular to VP. First position. This is second position. Then third position or third position. Anything will do. So this is alternate position is this. This edge on HP is away from VP or nearer to the observer. Normally we take like this for space management. What we do is we take this line nearer to the XY line so that you can have the sufficient space for the third figure top view. Okay. So you can try this longer edge on HP, and this is the standard problem on planes. If you work this problem carefully, you can work any problem on planes. We will see the same information in the computer software. So let me review the concepts which I have told you already. Let me take a simple problem on lamina in first quadrant. 60 mm by 40 mm lamina is 25 mm in front of VP with one of its longer sides 30 mm by HP. So you can see the 3D model. Here the colored one always gives you the actual lamina ABCD capital, and then if you project on the VP you will get A dash, B dash, C dash, D dash, and this is the top view. So as you know, the front view is same rectangle of 60 by 40, and then as with respect to the XY line, so whatever you do here that is for HP and whatever you do there is for VP. The lamina is parallel to VP and 25 mm in front of it. I can say the lamina is parallel to VP and 25 mm in front of it, and the one of the longer edge is 30 mm above it, and the true shape is in front view because the lamina is parallel to VP. So this is what the simple projection of planes. Okay. Now I can have one more figure. It is horizontally placed. One of the longer side is parallel to VP, and the lamina itself is some distance above HP. We say 30 mm above HP, and one of the longer side is 25 mm HP. So here you can say the front view is a line. If you look from front, definitely since it is perpendicular to VP, whatever the situation, the lamina is perpendicular to a plane. On that plane you get a line as a reference, and if you get parallel to a plane, on that plane you get true shape. Okay, on that plane you get true shape. Top view is true shape here. Okay, so same thing with some specifications I have given. So 30 mm HP, 25 mm in front of VP. So definitely the top view will be the true shape, and the front view is a line 30 mm HP, because if it is on HP, definitely it will be on XY line. Anyway, we will show you how exactly. See, I have taken one surface on HP. Okay, so on HP, that means your front view is on HP, on XY line. The top view is 30 mm in front of VP. Okay, so definitely this distance is maintained, say 25 mm, this distance is maintained, and the true shape is available 60-40. Okay, now the lamina is, instead of in front of VP, the total lamina is on VP. That itself is true shape, and also the front view. So I have coincided A dash with A, B dash with B, because since it is on VP, that itself is top view. Assume that you remove the actual plane, you will get the same impression because of it's on VP. Even if it is in front of you, you will get same thing, true shape now. Then you look from top, because it is on VP, the projection, that is top view, will be on XY line, because zero distance from VP. So this is front view, this is top view. Next comes I have told you how to manage naming. Now let me take these 4 figures. People take these some books also. So better avoid that, and you get the correct answer, but it leads to confusion for both teachers and also students. Okay, now this is best way of working. You are looking from this direction, you can nearer to you is AB. Okay, only these 2 points are visible in front you, A dash, B dash, and invisible points are seen. In top you will get everything. See, no bracket. Why you keep it in bracket? Because invisible points should be placed in bracket. First visible points start from left extreme corner, then remaining points will be invisible. Whichever invisible you keep it, okay, bracket. That is about the front view reference. Here the top view reference. Okay, here the lamina is parallel to VP or on VP. Definitely you look from top to get the top view. So visible points are A and B. So mark it first, start from left extreme nearest corner, then try to keep this invisible point BC. So this is what the reference is. Yes. See, a rectangular lamina of 60 mm by 40 mm has one of its short edge on HP, the lamina being inclined at 45 degree to HP. Draw the projections when the edge on HP is inclined at 30 degree. Whatever we have worked out, same problem I am taking now for better understanding on computer, how to work on computer. Again, shutter edge on HP is inclined at 30 degree to. That means the edge on HP is inclined at 30 degree to, not the lamina. Lamina inclination is given here. The lamina is inclined at 45 degree to HP. Okay. Now, let me note down what exactly given. Lamina inclined to HP by 45 degree, and one of the shutter edge on HP that is inclined at 30 degree to EP. Fine. Now, whenever you get this information, lamina is inclined to HP, you should decide that it is the edge condition with respect to HP, because the surface inclined to HP means you make it parallel to HP. Okay. So, better you make it parallel to HP and then make it parallel to HP, or keep it on HP. In this case, you have to keep it on HP because one of the shutter edge on HP. To get true shape on HP, so top view is true shape. Hence, start from top view. Many times people say from where you start, whether front view or top view. Definitely, this particular problem is from top view because I have given the reasoning also why you have to start from top view. Now, the question of what to keep, right extreme, left extreme, what you do, whether edge perpendicular or whatever, smaller edge or longer edge. The edge condition, the shorter edge on HP is given. Definitely the edge to be placed on HP is always perpendicular to VP in first figure top view. So this is what the information. So we have to start, and totally I call this particular condition as a edge condition with respect to HP. The lamina inclined to HP and something on HP means always it is edge condition. It can be corner also. In that case, you call that as corner condition with respect to HP. Okay. Now let us move on to the actual situation. The first initial position, I refer this as initial position. I have also noted this AD is to be placed on it. We can keep BC also, no problem. But normally we keep for space management in further problems should not get any difficulty. So naturally we keep DA or AD as the reference. Okay. Now you see this is the edge to be placed on HP, always perpendicular to VP, so that you can rotate the lamina about it and then get inclination only to HP. So this figure is dedicated only for initial position. Now let me start. Okay, how to start on computer. So now take this rectangle by 2 points. It's always better. Shorter edge. So you maintain some gap. Okay, and then 2 points. See, first longer edge is this. It is giving gray, blue color. That means you have to fix it 60. Fix 60. Then the longer side, shorter edge is 40. Check twice. See that it is perpendicular. See, this particular line is perpendicular. So this is the creation of this, how you create rectangle. Now dark this figure because this is the top view. Okay, you must keep this. Maintain 0.5. Initially also you can do it, but you can do it after some time. Okay, I think it is not done. See that it is black and 0.5. Yes. Now You see, got dark color. Now name these points. Extreme next left extreme nearest corner only should select first, naming to start, and sufficient font you must maintain, okay, as per the requirement. So this is A, B. Normally we give A, B, C, D. Okay, A, B, C, D. Okay, keep little away from the figure. Okay, and then dimension it. This is called smart dimensioning. Already we used it in straight lines and points. Okay, now keep this little away from it. That's all. So if you feel that this lettering are little close, you can even change it afterwards. You can use select command and then rearrange. Okay, it's not a big thing. You can rearrange. You see that diminishing line should not cross those lines. So don't kill letters. Okay. Now take this top view and then project that top view corners onto the print. Where to project? Because it is on HP, the one of the shattered edge on HP. If you rotate about that and make it parallel to HP, that means it will be on HP only. So definitely all the corners must be on XY line only. Don't project unnecessarily. Project see that this is thin line, yeah, 0.13 is maintained, and you get that symbol on that particular line, on that point on the line, symbol will be coming. Okay, you can stop there. Then dark this gap, that is from this point to this point, that is front view, that is representing front view. Okay, so again take line command, then make it 0.5, 0.5, start from this point. This. Now let me name this. Okay, or usually you can name and do it, otherwise you can dark that line and then name it. Normally you forget to dark it. So this is A dash, because it is front view, in bracket D dash. A is visible, D is not visible. Similarly, this is what B in bracket B dash in bracket C dash. Okay, so this is how you get the first figure, front view and top view. See, that is what I have done. Here the okay, here instead of 60/40 it has come 30. Anyway, in future let me take this as 30 only. See, I don't know, yeah, it's 30 only. Please see that it is 30. Okay. That yes. Instead of 60/40, take it as 30/40. Okay. Okay. Now, just observe here here I have the lamina 60/30. This particular edge is perpendicular. I have projected it and got it. Now to give the inclination to the HP. So to give inclination to HP, you have to directly we write manually. Here we cannot do that, because we can do it, but we have the functions and also the facility here. What you have to do is move and rotate. Now I will show you how to move and rotate. This is very important in solids and laminate. The entire thing you select. Okay, and here there are two items you have to control. One is this without shading, with shading. With shading refers to if you move this object, the object's availability is available here only, and also the one which you have moved. Copy, you are going to copy this here. The existence of both is available. But in case you make it light, okay, then the one which you have available, it will be disappear. It will come here. You will not get in both points. So better you keep, in this case, okay, keep this shaded so that you retain here only and also this. Now you move this. Just You can take any, if you want, you can simply move like this. But better you take a particular reference and do it. It is easy for you to place it on the line. Otherwise, you have to struggle a lot to keep it on XY line. Otherwise, it will be above or below. Now, you take the end point, better move. Okay, move and keep it on that. See, you will get the symbol arrow with line. The crossed arrow and line will come. That means you are keeping it exactly on the straight line available XY line. Okay, otherwise if you keep it random, you have to struggle for it. I am repeating this given reason. Now, after doing this, you have to rotate because the inclination of the lamina with respect to the HP is 45 degrees. So keep 45 degree. Okay. So how to do it? Again, you take same move. There only you have rotate. Now see, here you should not have this shaded one, because if you keep shaded one, then it will be retained both here also and here. But we don't want the one which you earlier. I will do both and see. Since it is first problem, you will come to know what is the difference. Now, assume that I don't keep this. I remove that shading and then do it. Okay. Now you take this reference end point, and then you need not keep at the end point of the front view. You can keep further move also. Then you give inclination to the HP by 45 degree. Yes, 45 degree. Directly you can give 45 degree. Okay. Now just check. See whether you want this way or this way. Yes, this way. Okay it. Then confirm that by clicking left click. Then you measure whether the value you are given is correct or not. Yeah, 45 degree. This is true inclination. Is there? The first stage there is no problem. Second stage, that to take true inclination, apparent inclination, or to think twice. Before that, let me have this. Okay. Now that is what we have followed. See here, the edge on HP, the smaller edge AD is on HP, that is perpendicular to VP. The lamina is inclined at 45 degree to HP. We have done that job. Okay. Next, what you have to do? We have to project this. See, you have to project this and get the top view. See here, yeah, it's 30. I don't know what happened. Okay. Now, the projection, how to do the projection. See, here unnecessary lines you should not do. So, keep only the required lines only, that is construction line. You first fix the right extreme line and the bottommost line. With alignment indicator you can do easily. See, that's what. Don't cross this line. Any number of projection, it can be 10 or 15 or only 2 corners. You project only up to this from the front view, top view, and then from front view you do this. That's all. Here very minimum is there. You have 1, 2 more. Keep it here and then keep this here. Okay. And this is how you get the apparent shape. Apparent shape you are going to get. Okay. So you are going to get apparent shape. See, this is how what you do. First you take the extreme line and the extreme line and then project here. You get the apparent shape. Next comes this. You dark it. Take 0.5 and dark. This is second figure, top view. Okay, where it is there. So this is the top view, front view. You got it. Next comes the, see here what you have to do is, right now it is perpendicular to what? Perpendicular to HP. I don't want here. I want the edge on HP inclined at 30 degree to VP. So what you have to do is, you have to keep this 30 degree. So whatever you did for this, you move and then rotate. Here also you would have to do it. So what I did, I move this to suitable position. Then how to move I will show you. Now how to move and rotate I will show you here. take this move command. See that this is shaded one because you have to retain here also, and then block it, entire thing. Then we take this reference, one corner A or D. We keep it somewhere here because I want AD nearer to the VP. Take little away from it and then keep it. Okay, that's all. This is how you do it. Then how to rotate? Again, same thing. You take. We are in the move command. Now you confirm rotate command, and in rotate command you should see that this is not shaded because both should not retain. Okay, you want final one. So you block it again. Then see that this DA should be inclined at 40 degree to XY. This is very important. Not with vertical. So if it is 40 degree with the 30 degree with the XY line, what you should do with for the vertical line? 60 degree you have to give. And finally you can check. Enter. Here you want or here? Here. You want here. Now check this with the angle. How much you got it. So this is how you try to rotate. Move and rotate. So this is what I did. See here I moved it to move the second figure top view to a suitable location, to draw the third figure top view by rotating by 30 degree to XY line. That is what I did. Okay, so this is what I did. See, this is what I did. Now this is the procedure you have to follow. Now project this. Okay, point. See, AD is very much on XY line. That's why I have given exclusively for this one slide. This is AD must be projected only up to XY line. That's what I did on the board also. Next comes BC. Project it carefully up to this. Don't go beyond, because if you draw this line, you will come to know the stopper. So this is actually stopper for you. Now join them. So this is the final solution. That is what we get in the manual drawing also on whiteboard. Same thing I would like to give information. Now I told you, you try with longer edge. Okay, before that let me try. If this AD is away from observer, away from VP or towards here, it is away from observer or nearer to VP. If it is away from VP or near to observer, that type of question will come sometimes. In that case, what you have to do is, you have to rotate here. Instead of AD nearer, you take away from it. So for that, what you have to do is, you take little away and then do it. Okay, this is how you maintain. So this is what the alternate solution for the first problem. Okay, here alternate solutions I have given. Instead of AD nearer to XY, you take away from XY line and then draw it. Okay. Next comes the longer edge. See here he says, that's what I have given for you to try. A rectangle lamina of 60 mm, 40 mm, anyway it is 30 mm in case of it. Longer sides on HP. The lamina being inclined at 45 degree to HP. Draw the projections when the edge on HP is inclined 30 degree to VP. Again same type of comment I have done. For understanding purpose, lamina is inclined to HP by 45 degree. One of the longer edge, this is what the change we have when compared to the previous problem. Longer edge on HP instead of shorter edge, that is inclined 30 degree to VP. So what is initial position? Initial position is surface condition. The lamina inclined to HP 40. So make it parallel to HP or keep it on HP to get true shape on HP. So top view is true shape. Hence start from top view. Definitely should start from top view. Now corner edge condition or corner condition. Actually edge is on HP, longer edge. The longer edge on HP, the edge to be placed on HP is perpendicular to VP in the first figure top view. So this referred to as again the edge condition with respect to HP. This is what the edge condition with respect to HP. So here is the pictorial view of the problem. So longer edge on HP, okay, perpendicular to VP. So this is what the orthographic projection of the same. The edge to be placed on HP is perpendicular to VP. So now this is the initial position, and then you have to go for inclination. Okay, move and rotate. Then try to get the top view. Again I have shown you AD, longer edge on HP perpendicular to VP. Then the rotation must be done, move and rotate. Okay, the longer edge AD is inclined at 30 degree to VP. Actually it is true length and true inclination. In future I always say TL on TI, because it is very important when it to deal with the beta problem, that is apparent angle problem. That's why you should confirm whether it is true length. Yes, this is true length, no change in bend. Definitely true length always associated with true inclination. Then comes the projection of the same AD on HP, very much on HP in XY line, BC above it accordingly. Then you are going to have this final solution. Okay, so this is how you work out a problem on triangular lamina. Then again the longer side on VP, how to deal with the problems on VP. Okay, we will discuss in future.